Thank you, Benjamin, for being here at Colombia for the PyCon conference.
Totally my pleasure. I'm having a blast and learning a lot.
Okay, so as a starting question, could you give us like a brief overview of like your career path on GIS or how you started in Geospatial?
Oh boy. So I majored in Chinese in college.
Okay.
And was pretty naive. I got out of school and realized I was quite surprised that there was nothing I could do with it, given I didn't want to go on and become a professor of Chinese. So I had a little bit of a soul searching, and one other big interest of mine was environmental, sort of understanding how ecosystems worked.
Okay.
And I got myself into a planning program at Penn, and hadn't really touched computers until then. I mean, this is like the late 80s.
Okay.
And just randomly took a GIS course, and I really liked it. And it was like, wow, Suddenly I had always loved tinkering. Like I built go-karts and, all kinds of things when I was a kid. Bicycles, and I had a bike shop, and so I loved working with my hands. And suddenly this seemed like a way I could build things almost more quickly, more cleanly, and at scale. I was actually thinking about scale even then, because I had this idea that, well, geez, I mean, it's easy to fit this stuff into these systems. At this point it was really CAD, so Intergraph, and early version of ArcInfo. And so I had these ideas of building inventories and things from at that point. Then I got really lucky, and I ended up doing my thesis with this GIS professor named John Radke. He was not given permission to set up a GIS lab at Penn,
Okay.
but the folks at Berkeley were happy to give him a lab. So the year I graduated, he moved out to Berkeley, and he took a bunch of us with us, and we helped set up the lab out there. And that was a great learning experience. And then I've worked in various, there was also a consulting firm associated with that I worked for some time. And then ended up moving back to Philly. My wife needed to finish her dissertation back at Penn, and started the GIS group for a transportation planning firm, so kind of got into the consulting. Then a state agency down in Florida, one of the biggest GIS operations. I got to manage their land management system down there. So already there's sort of quite a few angles on GIS that are sort of building up in my mind. And then for family reasons, we had to move back to Pennsylvania and back into consulting. And it was then really, I was working at PennDOT and Pennsylvania Department of Transportation, and feeling pretty frustrated because I was spending most of my time not doing GIS data set building, not doing analysis, but really messing around with just getting systems to talk to each other. Licensing stuff and that kind of thing. And I stumbled on this book by Eric Raymond called The Cathedral and the Bazaar, where he lays out does an ethnographic study of the hacker community. And that just blew my mind. Suddenly I understood that there was this really vibrant community there. It was kind of behind the scenes I hadn't been aware of. They were doing technology, and what if I could find open source GIS technology? Because I had never heard of it, and there really wasn't very much at the time. You had to really dig. But I also had in the back of my mind, this could be a nice way to extend the business model of the consulting firm that I worked for. Because at that point we only offered ESRI proprietary solutions, and I like blasted into my boss's office one day and said, we got to start offering our customers a choice, right? We call ourselves an independent consulting firm, right? Let's offer them open source and ESRI.
Okay.
And we'll come out the same, because we'll do the requirement studies, we'll do the programming, the integration, and the customers, if they go with a proprietary, they'll be spending $50,000. If they go with open source, they won't have to pay anything for software.
Okay.
And that ended up working out pretty well. And so I started getting into open source GIS, started to build some systems for government agencies, pretty effective. Like they were really fast, and at that time, big data for that time. Somehow I also got this idea in my head about peer-to-peer GIS. It occurred to me that we could set up a lightweight map server instance, and it could run locally. Like we could create a Mapster situation where everybody in the world who had maps on their desktops could share them through a Napster-like central index.
Okay.
And my boss was great, and he said, well, let's see if we can build a prototype. And we got to demo that at the UN summit in South Africa.
Which year was that?
That was 2002.
Okay.
Yeah, we linked together like 6 servers across Africa and had them sharing maps in the same view. Like one layer was coming from one server in Africa, one was coming from another server in Africa.
Okay.
And it was pretty cool, for that time. In fact, you don't really see a lot of that now. And then somehow so at that time, 2006, that takes us up to like 2007, starting a GIS lab up at Harvard. Okay. And they were bringing together a variety of people, and I sort of fit in as one of the kinds of GIS people they wanted, and so we ended up moving up to Boston and building systems for scholars to support scholarship that involves geospatial information.
Okay.
That was kind of a long-winded explanation, but it kind of gives you a sense, a little bit of a picture. So early on at Harvard, we were approached by a professor who had a hard drive full of data on Africa, and she wanted to build a web-based system. She wanted to get her data up and out into a spatial format, and she wanted to be able to share that with other scholars, and she wanted to be able to easily bring in other layers. And so we developed something that we called Africa Map for her. It was really a one-off solution, but we show it to groups around Harvard, and they'd say, wow, that's fantastic. Can you do that for, China? Can you do that for Chicago? Can you do that for Vermont geology? And to which we said, yeah, sure. We'd clone the system and load new data to it, and we ended up building a bunch of separate systems, which of course became very inefficient to manage very quickly. And we decided to go with a content management system approach, and that was where the world map system came from.
Okay.
Let people build their own map collections and let people curate their own geospatial information.
Okay, thank you for your overview.
Mm-hmm.
We have in one hand, for example, cartography. We have maps and geography, and we have in the other map technology. So there are like different tools, like electronic circuits and things. What do you think is the definition of GIS? What is like a bridge between those fields, or?
That's a good question. So yeah, GIS does include elements of both. I think it is very much a hybrid field. I'm not sure you can call it a field exactly, but I think now more than ever, as geospatial data makes its way into large databases that are that are being built for many reasons outside of the traditional geospatial space.
Okay.
GIS is becoming rapidly more a part of IT than it is of geography.
Okay.
I mean, geography still matters a lot, and smaller traditional geospatial data sets still matter a lot. Visualizing those easily within desktop systems is still very useful and important, especially for anybody getting into the field.
Mm-hmm.
But I think more and more, if you were to stand back and not think about the terms as much as where geospatial information is getting used and massaged and repurposed and visualized, it's more and more happening outside of GIS or geospatial, and by people who wouldn't call themselves geospatial technologists even.
You were talking about world maps, the project that people can create maps and share layers of maps.
Yeah.
Because this is a Python. This is a Python project.
Yeah.
It was based in Python. It's a Django project.
Yeah.
I suppose there could be like many pitfalls or many issues regarding to that project. Could you give us like a brief overview of that project?
So it's been really good. We've had some wonderful developers work on the project. We found Django itself to be extremely powerful for our purposes and flexible. We've learned a lot of lessons, particularly with regard to heavily building on an existing project. So we built on GeoNode, which is based on Django. And this is, starting in 2010 or so, we had professors coming in with needs, really rapid fire. And we were able to build World Map quickly by forking GeoNode.
Okay.
Our intent was never to fork it as deeply as we did, but we never had the time or the resources to move everything, upstream. And so we ended up, way down the road, and finally deciding to migrate back to the mothership, and that process we're now just at the very end of. It took probably a year and a half longer than we thought it would, but it's been an amazing experience, and we've had some great people working on it. Including Ariel Nunez.
Yes.
You had a hand in part of it. Paolo Corti, who has really spent the last couple years working on it, doing amazing stuff. And then the original developer was Matt Bertrand, who was really laid down a lot of code that's still really pretty much untouched. It was really strong.
Exactly. World Map is an open source project, right?
Yeah.
In GIS, like the GIS community, they share like all the tools, and people can use their tools they develop with no issues.
Yeah.
What do you think about this approach of this revolution of open source software? Because, for example, Phosphor-G is a really important conference.
Right.
When people share what they have done.
Yeah. So geospatial has really moved into the mainstream in the last, say, 6-7 years. I'm not sure how long Phosphor-G has been going on, but I would really mark it probably with the beginning of Phosphor-G. GIS coming out of this kind of very, quite a narrow little branch of IT, and coming out into the mainstream through open source.
Yeah.
Because suddenly geospatial, even just the word geospatial rather than GIS, is a move into the future, and a way of describing the technology in a way that traditional IT people can understand and value. And when you open source all of these components, you make them usable in all kinds of other systems.
Yeah.
So for a long time, geospatial, the geospatial technology world has always kind of been balancing between proprietary systems and open source. And in the early days, the proprietary systems were really dominant. And I would say, in many ways, in a very good way.
Yeah.
So, I mean, the first programming language I really learned was AML, Arc Macro Language. And it was an incredibly powerful language and a lot of fun to program in. And in terms of, amount you could do for the code, I mean, there's nothing like it. I mean, even it might even hazard to say that you could do more with less code than Python.
Okay.
But it doesn't exist anymore.
At Harvard, the Center for Geographic Analysis, the group of people that you work with, you have also other projects that you have developed. For example, the BOB, the Billion Object Platform.
Yeah.
Could you give us like a brief overview of that project?
Yeah. So the BOB came out of actually some technology we developed for making geospatial data easier to search.
Okay.
In a project called Hypermap. We wanted a way to let a user visualize the results to a query interactively, even if that query was going against tens of thousands, hundreds of thousands of layers.
Yep.
In a database, in a metadata database. And so we ended up building something we're calling 2D faceting into Solr. So we took a Solr search engine, which is, of course, is very fast and powerful based on Lucene, and extremely fast at faceting, and basically said, let's make spatial facets so that we can render heat maps really fast against very large data sets. Because that was always a bottleneck in GIS systems. Anytime you've got more than 1 million points and you want to do interactive queries, doesn't matter if you're on a web server, desktop, it's going to be slow. Exactly. So that's just like a core issue with, a core kind of fundamental tech issue with geospatial systems. And we kind of broke that with this 2D faceting. And so we were excited, and we were able to get a grant through Sloan to do an experiment to extend 2D faceting to 1 billion objects.
Okay.
And this was really that attempt to see how far we could scale it. Yeah. And we succeeded. It was harder than we thought it would be. But part of the problem was that we were building it on a research cloud that was still being built.
Okay.
As we were trying to build this, fairly large distributed Solr cluster, and so we solved the problem, and then we had to shut it down because the research cloud was sort of having issues. But it's all on GitHub.
Yeah, it's also open
and
source.
I think there's some interesting code there that could be brought forward and used to build some a big data visualization system that. So one of the cool things about the platform is, so we had 1 billion geo tweets, so 1 billion geolocated tweets in it. Of course, each tweet has a timestamp, so we could do spatial and temporal faceting, as well as keywords. And we also built a sentiment stamper. So this was also a streaming system. So tweets were flowing in to the billion object platform, and they were being brought off the back end as it filled up. And as they were coming in, we were stamping everything with sentiment and canonical geospatial boundary, so that every tweet would know, what census block it was in, what country boundary it was in, what zip code it was in, which would enable us to do really fast queries and analysis in it in various aggregated ways later. We never got to that part.
Okay.
But fair bit of the infrastructure is there for doing that.
Exactly. Another thing is that geospatial data, there's like a lot of information to store and also to search, right? The Bob has that issue.
Yeah.
You talking to you previously, you were talking about like using GPUs in order to increase performance.
Yeah.
Could you explain like a little bit more about that technology?
Sure. Well, we were actually fortunate to have a few years ago a student came in. He was a Middle Eastern Studies student, but he also happened to be a world-class developer, which I didn't know at the time. And he had millions and millions of tweets that he wanted to be able to visualize. He had ideas about doing it on a GPU. And I said, wow, this sounds interesting.
Yeah.
So we worked together for about a year, and we helped him figure out how to basically build a map service out of a GPU that could feed into any other map system, basically. So it was about the interface, the API for a standard API for a GPU-based GIS, and worked really well. We built something called TweetMap, which we plugged into WorldMap, and it was a cool demo. He moved on to MIT, where he then worked with a couple renowned database professors and did a startup. And he now is out in Silicon Valley. The company is called OmniSci, and I think they've now successfully, second round of funding, and they've open sourced their core technology, and we're working with them on a bunch of research use cases with that platform, which is really exciting. So in terms of storage, it's interesting because part of the challenge is moving data on and off of the GPU between CPU, RAM, and GPU memory efficiently. That's what they've figured out. That's really tricky stuff. But what GPUs do, in a way, is they solve the problem we were trying to solve with rendering large numbers of objects super fast. They do it much better than the BOP did. But the BOP has some capabilities that OmniSci doesn't have. But I mean, GPUs are really interesting from the perspective of rendering on the fly maps that are perhaps analytical on maps on the fly against a large geospatial data set. Which is exciting because it provides a way, in addition to a machine learning approach, for a human to explore large data sets, and see the raw data, right, and develop hypotheses around that, which otherwise is very difficult.
Well, there's like an increasing number of like geospatial developers, and recently people are starting to write code and related to GIS. What is like the advice to people to start that is starting? Because, for example, when I started, I realized that there were like so many tools created, and they were in Python, so I didn't like know that. So it was like trying to understand things, but there's a tool that does it.
Mm-hmm. Yeah.
Well, what other things you can tell them?
That's a great question. I think if somebody's coming from a database or a developer background and they don't know much about geospatial, a really good way to start is probably with QGIS, which is a really powerful open source desktop GIS. And the nice thing about it is it provides a really nice workbench that they can use to start exploring the different kinds of geospatial information. Right? And if you don't understand the different kinds of geospatial information, then it's going to be really hard to use command line stuff to get leverage over it and do fancier things. And you also kind of need to understand projections. So QGIS is a great way to start bringing in raster data, which is image-based data like satellite imagery, vector data, which is points, lines, and polygons, bringing them together, looking at how different projection definitions work, building data sets in QGIS, small ones, using existing data, which is, for which QGIS is really plenty powerful, like census data, symbolizing stuff. And then the nice thing is there are all kinds of plugins that have been built in QGIS in Python.
Okay.
Right? So they could start looking at how those plugins are built and see how they work. And they could think about building a new plugin as a way to start kind of in a very grounded way to think about Python and what tools they might need to do something practical in an actual in an actual platform where they can visualize the results, which is pretty key in geospatial.
Okay, and also there's like this machine learning has raised in popularity, right? And there is like a lot of data collected from GIS, geospatial data. What do you think about, or what is your opinion about using machine learning algorithms or methods to that data?
I think it's super exciting. I think, especially because I don't think it's been done very much. I think I'm not an expert in that, but my understanding and from what I've seen, most machine learning really doesn't think about space in a very sophisticated way, and I think that's partly because it's not easy.
Okay.
But that makes it exciting from a research perspective. So I think there's huge potential in bringing those things together. And there's a package called GeoPandas, which is really, I think, a great, place to start.
Okay.
Because of course you've got all the power of pandas, and then you've got a bunch of powerful spatial libraries right there, and you can start doing manipulations on large data sets, and then visualize the results. There are ways of aggregating that so you can visualize it in QGIS or something, and then there are other tools that are coming along. I think that's a very exciting. It's wide open, I think.
Okay.
Yeah.
And just a final question: what do you see, or what do you think about the future of GIS? Because there are so many, there are different fields and branches of GIS. For example, spatial database infrastructures. It is about privacy and security, satellite imagery. What do you think about the future? What do you think about many developers that are going to start?
Well, space is pretty fundamental, right?
Yeah.
It's always going to matter. Where things happen matters.
Yep.
In some cases, very, very much. In some cases, not so much. But even if it's not so much, being able to quantify that error, if you're looking at trying to characterize phenomena, it's really important. So one way or another, it's going to be important. Whether you call it GIS or geospatial, or it's just machine learning and it's just assumed, as we assume so many types of analytics already without calling it something, right? It's just machine learning. Yeah. So I think it'll get subsumed under machine learning and, and that world of data analytics. But I think there'll always be, because we'll always need maps, there'll always be the need for cartographers or the equivalent thereof, that is people with a graphics understanding and ability who can make maps that really make sense. Because the more data you have, actually, the more difficult it is to make a map that makes sense to a person that's not a geek, not already in that fold, area. Right? So, so I think we're gonna continue to see at least those two tracks and many others. Car navigation is at core a geospatial optimization operation, or at least that's a really important part of it. Satellite imagery, remote sensing. We've got climate change, whether we think it's man-made or not. We need to do, there's a lot of work in terms of figuring out what's going on. A lot of that's being, the information for that is coming from, remote sensed imagery, which is geospatial data. That's a whole other field, right? Remote sensing. Bringing remote sensing data in together with stuff, that we know about on the ground. that kind of fusion is a huge area, right? Huge big data area. It has all kinds of applications in agriculture. It's being used for surveillance in various ways, all over the place, all over the world. And it's, you know, broad array of directions it's going to be going. It's going to be interesting to see what you know, looking in a few years, looking back and thinking, you know, I wonder whether we'll still call any of this GIS anymore. You know.
Okay. Well, Ben, I think that's all the questions that I have. Thank you for being here. Enjoy the rest of the conference.
Thank you very much.
Okay.
It's been a great pleasure being here.
Okay.
Yeah.